Okay, hi everybody. So in this video here, we're going to continue our talk about transformations, but this time we're going to talk about translations. And when we talk about translations, what we're talking about is really just moving a graph. We're going to change its position. So we're not stretching it. We're not changing what it, like its shape in a sense. We're not changing its orientation, flipping it, reflecting it, and whatnot. It's like what we're doing here is we've got a parabola like this. Let's say here's my parabola. And then what I'm going to do, oops, is move it. Okay, just move it back and forth or move it up and down. Okay, but either way, that's what we're doing with this particular lesson here is we're moving it here. Now, because we're doing that, because we're moving it here, there are no invariant points. Okay, everything changes when we do a translation. Everything changes. Okay, now let's take a look at how this is going to work algebraically. So a horizontal translation, we're going to move the graph left or right. I want to make sure that this makes a lot of sense because there's a part of this that can be a little bit confusing. So here we go. We've got our original graph, y equals f of x, and I'm going to replace x with x minus h. So for example, I might replace x with x minus 2. So in my function, this is going to look like this, f of x minus 2. But what that does is it moves the graph to the right. And I know that that looks a little weird because just inside here, I've got x minus 2. And subtraction would typically imply going to the left. But in this case, we are actually moving to the right. And what I would have to do, my mapping, what is actually happening to the points on the graph is I've got to take all the x coordinates, I have to add 2 to them, okay, to perform this transformation. And I want to explain why so that you get a better sense of what it is that's going on here and why it is opposite to what you're seeing in the transformed function. So I'm going to use an example here. I'm going to say we've got y is equal to x squared. Now, this is going to be my old y, and this is my old x. This is my original. If I wanted to figure out what my old x was, and I knew what my old y was, to get x by itself, I would take the square root of my old y. This would be my old x. And here I go. And I got plus or minus there. So x is equal to plus or minus the square root of the old y. That's what I would do. Okay. If I knew that y was 9 and I wanted to know what was the x coordinate, I would take the square root, get plus or minus 3. Well, what happens if I take that function, that old one, so I've still got my old y, but now what I'm going to do is I've got a new x, and I'm going to subtract from that 2. So I'm replacing my old x with a new x minus 2. Well, okay, if I was to figure out what x is, if I knew what y was, just like I did in the previous one, if I knew y and I wanted to get x, I would take the square root, plus or minus square root of the old y, old y, and that would give me x new minus 2. And then to get the x new by itself, that new x coordinate, I would have to take the old one. Now remember what's going on here. This plus or minus y old is not a y coordinate, it's the x coordinate. That plus or minus y old, that is equal to the old x coordinate. So this is the old x coordinate plus 2. Okay, so my new x coordinate is the old x coordinate plus 2. It has increased by 2 because in order to get the x new by itself, I had to add the 2 to the other side. I had to move it over. And so that's why when you're seeing x minus 2 in the function, it actually means plus 2 on the actual graph when we talk about the actual points on the graph. That's why the mapping is like that. And then over here, if you're going to move to the left, what I would do is replace x in the function with, let's say, x plus 3. This would be f of x plus 3. But what that means, in order for me to get that x by itself, remember this new x by itself, I would have to subtract 3, okay, from the old x coordinate. And that's how I'm getting that. And that's why that moves to the left. Now, with the vertical transformations, it's actually quite similar, except for one little detail. We'll walk through like this. So I'm going to start with y equals f of x, and I'm going to replace y, let's say y minus 5. So this becomes y minus 5 is equal to f of x. here's the difference. When I'm dealing with a vertical transformation, I am actually going to isolate it. Okay, I don't typically isolate x the way I did in this particular box here. This just doesn't happen. That's not the way we kind of standard in a standard way we do that. We isolate y, not x. But here we do isolate the y. So what I normally do is I am going to take that this is my new one. This is my old y coordinate. I am going to take, to get my new one, my old one, I'm going to add that 5 to the other side. But I usually do that so I actually can see it. Okay, so now this simply means y plus 5. So that was 5 up. And similarly, if I was to replace y with y plus k, let's say it was going to be y plus 4. I get y plus 4 is equal to f of x. But typically I'll move that over, and so that I am actually going to subtract that 4 from the old y coordinate. And so that means it is going to be 4 down. Okay, so I hope that makes sense, because that tends to be a part where people get a little bit confused, where with the x, it's always basically opposite what you're seeing inside the function, if you want to think of it like that. But with the y, it depends on what side of the expression you're seeing that transformation. You just have to be a little bit careful about it. So now let's take a look at some examples. So here the question says, sketch the graphs of the following, state the function, the equation, replacement, the mapping point, the domain and range using interval notation. Okay, well, blah, blah, blah. Anyway, let's just jump in here. So f of x is equal to x squared. So that is going to look something like that, just a nice little parabola there. And now what I've done is I have replaced, so if I just think of it like this, to get g of x, clearly what I've done here is I've replaced the x with x plus 5, and then I replaced y with y plus 3, and then moved it over. Whoops. And that became minus 3 here. So what's going on here is this graph is moving 5 units to the left, so 1, 2, 3, 4, 5, and then 3 units down, 1, 2, 3. So my vertex is now right here. And then it's going to open up like that. So this function became this function right here. So right here, this would be my f of x. Over here, this would be y equals g of x. Okay, so now what happened to the domain of g of x? Well, nothing. Now, normally, a horizontal translation would affect the domain. I mean, it's not going to affect the range, but it will affect the domain. But in this case, because the domain was already negative infinity to infinity, changing that by moving it 5 to the left isn't going to change anything. But the range, however, will change. The range originally was greater than or equal to 0. Well, now we're going to be greater than or equal to negative 3. So it's going to be from negative 3 inclusive out to infinity. The equation of g of x in terms of f of x, well, I already wrote that. I wrote that up high there. So g of x was going to equal f of x plus 5 minus 3. Now, sometimes the mistake that gets made here is people wonder, well, what about the square? Where's the square in there? The square is represented by the function. The f here means, if you go back over to the notation, the f here means take whatever's inside the parentheses and square it. Okay, so the f is telling us to do the squaring. So when I have f of x plus 5, that literally means if I'm going to take g of x, to get that, I'm going to take that x plus 5 and square it. Whatever's inside there gets squared. After that's done, I would subtract 3. But what they want right now is they want this. My mapping refers to both variables here. It's the point, what's happening to the point in general. And that was going to be x minus 5 and then y minus 3. Old x gets adjusted by subtracting 5. Old y gets adjusted by subtracting 3. Whoops, sorry about that. Let's take a look at another one. Y is the absolute value of x. And we've got y plus 2 f of x minus 3. And we're going to graph this on the same grid here. Now, what has happened? Well, I replaced y with y plus 2, and I clearly replaced x with x minus 3. Normally, I wouldn't write it like that. Normally, what I would then do is bring that 2 over so that my mapping is consistent. But I just got to remember that I can put that the vertical transformation on either side, but this is going to be x plus 3 and y minus 2. There's my mapping. And so now it's quite easy because my mapping tells me to add 3 to the old y coordinate, subtract 2 from the old, add 3 to the old x coordinate, subtract 2 from the old y coordinate. So this is going to be negative 2, 3. Okay? 3, negative 2, 8, 3. And now I just go to my graph here and I plot those. So negative 2, 3 is going to be right here. 3, negative 2 is going to be right here. And remember, that's the vertex. Okay, that's where the vertex went. And then 5, 8, 5, 5 is going to become 8, 3. So 8, 2, 3 is over here. And then I'm just going to connect the dots. I'm going to make sure to put little arrows on there to indicate that that keeps going. And so my equation would look something like this. And I'm going to base my equation off of the function notation that I have over here, because I know that my function is the absolute value of x. So this is going to be y is equal to the absolute value of whatever's inside my function, x minus 3. And then because the minus 2 is after the function, I put the minus 2 outside. Remember, the f here, the function, is what changes the x coordinate into a y coordinate. So it's like what's happening here is the x is getting altered first, then the absolute value creates a y coordinate, and then I'm subtracting 2 from that y coordinate. Given the graph below, graph the transformation y minus 1 is equal to f of x plus 2 on the same grid and describe the transformations. Again, I would feel more comfortable if I isolated that y. But what I'm seeing here, this is a horizontal translation 2 units left. Because in order to get the correct transformation there, okay, I have to subtract that 2 to move it over to get what x is on its own here. Then I've got a vertical translation 1 up. And I know that's true because the y has been isolated. I have already moved that over. So it's already changed signs here. And so what I'm getting here is my mapping x comma y is going to become x minus 2, y plus 1. Now, I could go through and do each one of these points separately. In like list them off, get all the coordinates. Or I can kind of just do it visually. I'm going to move, for example, I'm going to move this point 2 to the left, 1 up. I'm going to move this point 2 to the left, 1 up. This point 2 to the left, 1 up. This point 2 to the left, 1 up. And then this point 2 to the left, 1 up. And then I just got to connect the dots. And there we go. And that's all you need. Now, before I finish this question here, one fairly common error, I know exactly what students mean when they do this, but it is still an error. I'll have people that'll say that this has been a horizontal translation 2 units down, or this has been a vertical translation 1 unit right. They give me the transformation, they give me the right quantity, but then they give me a direction that doesn't match what they just said. You can't go horizontally up and down. You can't go vertically left and right. Just please make sure that you're answering the question consistently. Okay, so now let's keep going here. The question says the point 2, negative 3 lies on the graph of y equals f of x. So this is an old point. State the coordinates of the image of this point under the following transformations. Okay, so now, but watch what this is saying here. This is not an image point. That's a replacement. Okay, so that is telling me what I'm doing to the function. What that does to the image point is a little different. That is going to make that x plus 7 comma y. So you can identify the replacements because it's just a single variable that you're dealing with. But the image point has both coordinates there. And all of the transformations that are present are going to be represented. So now I have the point 2, -3 is going to end up becoming, well, it's telling me old plus 7, so it's going to be 9, and then the y-coordinate doesn't change, so 9, -3. But here, notice that both points are represented. This is a mapping. So this is telling me what is actually happening to that point. I don't need to do anything else. Old coordinate plus 2, so 4. Old y-coordinate plus 3, 0. And there's my new, those are the coordinates of the new point. For question 5, it says here the point -1, 8 is on the graph of y equals f of x, so that's an old point. State the mapping notation used, the replacements and the corresponding point on this right here. Okay, well, the replacements are pretty straightforward because I can see them quite clearly. Y was replaced with y plus 9. X was replaced with x plus 4. I know that that means that that's actually 4 to the left and 9 down. So there's my mapping, which means my point -1, 8 is going to become, well, what I'm going to do is I'm going to subtract 4 from the y-coordinate, so -5. And then I'm going to subtract 9 from the y-coordinate, and 8 minus I is just going to be -1. And so there's my new point. Okay? Compare the domain and range. And you always want to be prepared for domain and range questions because they come up a lot. Of f of x is equal to x squared minus 3. Okay, under the transformations implied by y minus 2 is equal to f of x minus 4. Okay, now, first of all, I have to have a bit of an idea of what x squared minus 3 looks like. Well, it looks like a parabola that's been transformed down 3, so it's going to look something like this. Okay, where this is my -3. So my domain here is going to be all reals, so -infinity to infinity. And my range is going to start at -3 and go up to infinity. Now, well, what am I doing? I'm moving it 2 up. Because remember, I'm going to move that over. That's going to add, well, not 4, it's going to add 2 to that old y-coordinate. So what that's going to do now to my range, maybe I'll switch colors here so it's brand new here. My new range is actually going to be -1 up to infinity. Okay, but I also moved this thing 4 to the right. Except that when I have a domain that's -infinity to infinity, adding 4 to that's not going to change anything. So it's just going to stay the way it is. And so there we go. So that's the answer that we're looking for. The graph of f of x equals x plus 2 squared minus 4 is translated 2 to the right and 3 down to obtain the graph y equals g of x. Determine the equation of g of x. Okay, this is a good question, and I would like to star this one just to highlight its importance here, its significance. What I'm going to do right now is I'm going to answer this question in general. So my new g of x, is going to equal a transformation of f of x, and that's going to be 2 to the right, 3 down. Meaning I'm going to, inside f of x, 2 to the right looks like this. It's going to be x minus 2. And then to get 3 down, okay, I might replace y with y plus 3, but then I'm going to bring it over. So it's going to look like this. Now, the next step to create the actual equation is what I have seen. This appears to cause a little bit of confusion here. So I want to make sure that this is really abundantly clear. In the original function, so I'm looking back at the original function right here, okay? What this says is that f of x, what the function does is it takes whatever's inside the parentheses here, that x, what it does is it adds 2 to it, then it squares that result, and then it subtracts 4. Now, where I see problems lie is students focus on it's x. It's always x. You need to get away from that. Whatever's inside here, it adds 2 to it, squares the result, and subtracts 4. And the reason I say it like that is because you need to get the substitution correct here. So when I've got f of x minus 2, that means I'm going to take whatever's inside there, I'm going to subtract 2 from it, square it, and subtract 4. Okay? That is exactly what that notation is trying to get me to do. Now, that's just the f of x minus 2. Then what I got to do is take that whole thing and subtract 3 from that. Okay? And I've done this enough in class to know that this can sometimes really confuse people. So it's what's inside the function. I subtract 2 from it and square that. Then I subtract 4. That's the entire function. Then at the end, that minus 3 right there becomes that minus 3. So now evaluating this or simplifying it, inside the parentheses there, I've got x minus 2 is going to be x minus 4 minus 3. And then what I'm going to do here is drop that next set of parentheses, and we get x minus 4 squared minus 7. So with this question, it says, as a result of the transformation of the graph of y equals x cubed into the graph of y minus 4 equals x minus 3 cubed, the point 327 becomes the point 6y. And what's the value of y? Okay, let's just take a look at this. This right here, the function says that first of all, I can see that I've replaced x with x minus 3, which means I've got a horizontal translation 3 to the right. So my x comma y has become x plus 3 common. I'll talk about y in just a second here. And that makes sense because I see the 3 becoming a 6. Okay, perfect. Now, if I bring that, I should think of it like this. I replaced y with y minus 4, which means that in my mapping, it should be y plus 4. So what I'm going to do is take that 27 and add 4 to it, and I'll get 31. And that's what I'm looking for in that particular question. For this next one here, it says a function has a domain represented by this expression right here. So it's the values of x such that x is between negative 5 and 4, where x is an element of the reals. And a range represented by y is an element is found between 0 and 10 inclusive, where y is an element of the reals. Now, what's the domain and range of the image after these transformations? Well, what have we done? Well, we've got a horizontal translation. So this has been translated. Let's just say horizontally translated 6 to the right. Now, that's not going to affect the range, but it will affect the domain. And all I'm going to do is add 6 to the endpoints of my domain. The whole thing is going to slide over. So this is going to be a set of x values such that, well, negative 5 plus 6 is going to be 1, and 4 plus 6 would be 10. And then x is an element of the reals. And then I've got a vertical translate. It's going to be vertically translated. And I've replaced y with y plus 4, so it's going to be 4 down when I bring that 4 over. So everything's going to shift down. So the new range is going to be the set of y coordinates. And I'm going to go down 4 from 0. So 0 minus 4 is going to be negative 4. And 10 minus 4 is going to be 6. And again, where y is an element of the reals. Yeah. So it's easy enough. All I got to do is move the endpoints of the domain, and everything kind of stays consistent like that. We're almost at the end here. Let's take a look at a couple others here. What happens to negative 1, 6 if I translate it to left? So let's just talk about this. If I say I translate it to the left, I mean x minus 2, and 4 down is y minus 4. So negative 1 minus 2 would be negative 3. 6 minus 4 is 2. That would be my final point. If I replace y with y minus 2, that means that my graph has actually gone up 2. Okay? So in this case, in the first one, I'm describing the transformation, which is basically I'm telling you what's going on in the image point. In the second one, I'm talking about the replacement in the function. And I got to be careful that I don't mix those guys up there. And so now at the point 3, negative 2, well, nothing happened to the x coordinate, but I added 2 to the y coordinate, so that negative 2 became 0. Now here, I'm giving you the function, and so I know that I've gone 5 to the right, so it's going to be x plus 5, and I can see by the fact that the 4 is already on the side with the function, that I've already moved it over. So that means that is up 4. What that means is I would have been replacing y with y minus 4. And actually, I've already written the answer there. The answer is x plus 5, y plus 4. Now, finally, translated 6 to the right and 3 up means that my x comma y is going to be 6 to the right, so x plus 6, and 3 up would be y plus 3. Now, here's the difference. In this case, the point that I'm given is the result. I want to go backwards. So in this case here, it's not that I'm plugging in -7 to get -7 plus 6 is some new number. -7 is the result. So I got to go backwards and subtract 6 from that. I'm going to get -13 is equal to x. So that's the original point. And then -4 is equal to y plus 3. And I'll bring that 3 over and I get -7. And so the original point was -13 comma -7. Okay, and now if I move that 6 to the right and move that 3 up, that's where I'm getting the -7, -4 from. And now finally, let's take a quick look at this. We want to determine the equation of the function in that form right there. We just got to make sure that we're doing the right function here. We're starting with the dotted line. Now the assumption here is that we're not stretching it or anything like that. So we're just looking at the vertex really more than anything. How did the vertex move from there down to there? And I can see that it moved 6 to the right. So that means I'm going to replace x with x minus 6. And then I moved 7 down, which means I'm going to replace y with y minus 7. Plus 7. Plus 7 to move 7 down. So what I'm going to get in my function here is it's going to be y equals f of x is going to become y plus 7 equals f of x minus 6. The whole point of this question is that it's not that it's a hard question, it's just that we're giving you the information graphically instead of describing it.